Hi everyone, today we'll be discussing the LeetCode problem of the day, find triangular sum of an array. In this question, you are given a nums array and in that each digit will be from 0 to 9 and you have to perform few operations on that array until the size of the array becomes 1. So initially you have an array of size n and in first step you have to create a new array of size n minus 1 and in the new array new nums of I will be the value nums of I plus nums of I plus 1 mod 10. So that means in that new array, this value will be this value plus the next value mod 10. So 1 plus 2 mod 10 will be 3. Similarly, this will be 2 plus 3, 5. And this will be 3 plus 4, 7. And finally, this will be 4 plus 5, 9. Now the array size is 4, so it is not 1, so we keep repeating the process. So the new array will be 3 plus 5, 8 and 5 plus 7, 12, but we do 12 mod 10, so it becomes 2. And then 7 plus 9 mod 10 will be 6. And again we string the array. So 8 plus 2, 10, 10 mod 10 is 0. And 2 plus 6 is 8. And finally the array will be of size 1, so we just have to return 8. So for this input we have the output as 8. Now if we see the next example, we have the array given as only 5. Now since the array size is 1, so we just return whatever the element is, so the output is 5. Now let's go over the approach. So in modulus we have a formula like if we do a plus b and then take mod 10 and then add a c and then take mod 10 and then plus add d and then finally take mod 10. So this value is same as doing a plus b plus c plus d mod 10. So in wherever you take the mod in between or at the end, the result will be same. So while forming the array, we don't need to take the mod. So that means first we have 1 2 3 4 5 and this will be 3 5 7 9 and then 8 5 plus 7 12. We don't need to take the mod yet. And this is 16, this is 20, this is 28 and finally 48. So once we have the final answer, then we can just take a mod with 10 and we'll get the same value 8. So let's just keep this in mind. Now to solve the problem, we can just simulate this process n times, each time create a new array and form the values by using this formula and keep repeating it until the array size is 1 and then just take a mod with 10 and return. But this will be time complexity order of n square. Even though this will pass because n is only 1000, but we can optimize it further. So let's discuss that approach. Okay. So we have this tree kind of thing where the original array is becoming a single number 48. So if we see, if we try to see the contribution of each number, then we can directly add them instead of formulating all of this. Like if we can see this one contribution is only 1 in this 48 because this one will be added here and this will be added here, this will be added here and this will be added here. So this one contribution in this 48 is only 1. And similarly, if we see for 5 will be added here, then this number, these both will be added to 16. So that means this 5 is carry forwarded here, then it goes here and it goes here. So the 5's contribution in this 48 is also only one time. So we can say this 48 is formed by doing 1, this one plus let's see for 2, 3 and 4 contribution later. And finally for the 5 contribution. So now let's see the contribution for the remaining numbers as well. So we see that each number needs to reach the bottom. So this 2 has 2 options. It can go either left, it can go either right. And for this, it can go left, right, and here as well, left and right. And here you only have left. So the number of paths this 2 takes to reach 48 is equal to the contribution of 2. So for example, this 2 can go in four paths. First path is go like this, 3, 8, 20 and 48. And the next path will be go to 5, then go here and here and here. The next path, go to 5, go to 12, go to 20 and then 48. And the final path is go to 5, go to 12, then 28, then 48. So in total, we have 4 paths that is going from 2 to 48. So that means the contribution of 2 will be 4. So we can say that 4 times we have to add the 2. Similarly for this 4 as well, the contribution will be 4. So 4 times 4. We'll discuss how we end up at getting the contribution as 4. So meanwhile, let me just write this. So that means 4 times we are adding the 2, and similarly 4 times we are adding the 4. And this 3 will have the contribution of 6. We'll also see how we got to the 6. Now if we add this, then we have 1 plus 8 plus 18 plus 16 plus 5. So this is 20, 28, 34, 34, 35, 40, 48. So in total, we get the answer as 48. So now our only concern is to know the contribution of each element. So let's take this 2 and see. So this 2 has a few paths, like we discussed. It has 4 paths, and you have 2 options. Either you can go left or either you can go right. So we'll also have the indexes: index 0, index 1, index 2, index 3, index 4. Now for this 2 to reach the end, the first path is go left, then right, right, right. So in total, it needs 4 steps. The array size is 5, so it needs 4 steps to reach the bottom. So the total number of steps will be n-1. And in that n-1 steps, you need to make some choices. Either you have to move left or you have to move right. So the first path is left once and then all right. So left, right, right, and then right. Now in the second path, you go right and then left and then right, right. So right, left, right, and right. In the third path, you can go right, right, left, right. So you have right, right, left, right. And finally, right, 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 left. Right, 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 and left. So we can see that since this 2 is at index 1, the number of times we can move to the left is equal to 1 only. So if we see in all possible paths, the number of times you move left is exactly equal to 1. Because once you move to the left, that means you are at the extreme corner of the triangle and you can't move left further. So at index 1, you can only move left 1 time. So the number of paths is basically out of this n-1 paths, you have to pick 1 path to be the left. So we can say it is equal to n-1 c1. So in this case, it is 4c1, which is 4. Let's see the second example. I mean, let's see for 3, then it will be a bit more clear. Let me just erase this. Yeah, now let's look at this 3, which is at index 2. So for this 3 as well, we need to go down 4 times. And while going down, you can either go to the left or you can go to the right. And since this 3 is at index 2, you can only go to the left 2 times. So that means you have 4 choices. In that, any 2 will be left and the remaining will be right. Suppose we can have these 2 as left and remaining 2 will be right. So this means go left, go right, go left and go right. So this is one path. And suppose we take like this. 2 lefts will be here and remaining rights will be here. That means the path is like this, right, right, left, left. So this also we can think of as out of 4 choices, you have to pick 2 positions to be left. So this is same as 4C2. So 4C2 is 4 into 3 by 2, which is 6. So this 3 has 6 possible paths, so its contribution will be 6. So to generalize it, in this array, for any given I, if you want to know the contribution, it will be n minus 1 Ci. Okay. So once we have the array, we can simply say nums of I into it will be n minus 1 Ci. So this will be the contribution of each element, and you just sum it up over all the numbers, and that will be the final answer. So let's just see this for a small input. So we have the same input 1, 2, 3, 4, 5. Here n equal to 5. So for this number, we multiply it with n minus 1 Ci. Indexes are 0, 1, 2, 3, 4. So for this number, we need 4C0, and we need to multiply this number with 4C1. We need 4C2. For this number, we need to multiply 4C3 and then 4C4. So the values, I'll quickly write the values as well. This is 1, 4, 6, 4, 1. So this is what we discussed before. That are the contributions of each number. So to calculate these numbers, we can also do this iteratively, since we have a formula NCR equal to NCR minus 1 into N minus R plus 1 by R. So this is the formula we have. So using this formula, what we do is we first calculate this value, and so that means we have this term, and using the previous term we can calculate the NCR value of the next term, because R and R minus 1. So here see it is 1 and it is 0. So that means the first value we can easily calculate, because NC0, anything C0 will be just 1. So this value is 1. So from this one we can calculate this value. So we can see and this also, if we generalize it into our example, so we have n as n minus 1. So if the array size is 5, we need to operate with 5 minus 1. So we can have the formula something like this. If we want n minus 1 Ci plus 1, that means currently we are at this I, and we want to calculate the coefficient value for I plus 1. So that means n minus 1 ci plus 1 equal to n minus 1 ci into this n minus 1 minus I plus 1 plus 1 by I plus 1. So if I just expand this, this will be n minus 1 minus I minus 1 plus 1. So this will be n minus I minus 1 by I plus 1. So this is what the formula we have. Let me just write it clearly again. So that means if we want n minus 1 ci plus 1, we can directly get it from the previous value, which is n minus 1 ci, and to that previous value we just multiply with n minus I minus 1 by I plus 1. So this is what the formula we'll use. I'll just keep it beside. Okay, copy everything. Now let us quickly code it. So we'll first take int n equal to nums.length and int answer equal to 0. And also let's take a variable for the coefficient equal to 1. Initially this will be 1. So this means that it is n minus 1 c1, sorry, c0. Now based on this, we will calculate the further coefficients for I plus 1 values. So now let's just iterate on the array. I less than n I plus plus. So initially we have the coefficient n minus 1 c0, so we can directly multiply nums of I into coefficient and add this value in our answer. Answer equal to answer plus answer plus this value. After doing this, we need to calculate the coefficient for the next I plus 1. So we can use the formula as coefficient equal to coefficient into, so this coefficient into, we will have n minus I minus 1 and then we divided by I plus 1. So this is the new coefficient we have for the I plus 1 index. So after this, at the end, we just have to take mod and return answer mod 10. If I submit, this will pass the small test cases, but when I submit it, I don't think it will pass. Yeah, because in the constraints we have n equal to 1000. So 1000 C 500 is something very huge. So that won't fit in int or long range. So for that we need to use the big integer. So big integer n. For n we don't need it. For answer, and for the coefficient. And while returning, we need to first take mod, right? Return answer dot mod. We do mod with big integer dot 10. and when we do the mod, we need to return the integer value. So similarly, let us initialize the values. For 0, we should do big integer dot 0, and for 1, it is big integer dot 1. Now addition also, we can't do it straightforward. We need to use the add method. So answer equal to answer dot add. First, the nums of I, we need to multiply. We need to typecast it to big integer dot value of big integer dot value of nums of I into coefficient. So the above is converted as this in big integer. After doing this, again the same thing with coefficient as well. So coefficient equal to coefficient dot multiply big integer dot value of n minus I minus 1 okay, answer dot add coefficient dot multiply, we multiply it with n minus 1, and then the total value we do divide. Again same thing, big integer dot value of I plus 1. So this is how we convert to big integer. Let me just submit. Okay, what is this? Cannot find the symbol. I think we need to import for this big integer. Import java.math.big integer. And okay, what is the issue here? Answer equal to answer dot add big integer dot okay, we can't use normal multiplication symbol here, so we need to use the multiply method. So coefficient dot multiply, and that we need to pass this, and this to be commented. Okay, I think the issue is the coefficient will be big integer dot 1 because it is n minus 1 c0. Yeah, it works. Let me submit. Yeah, all good. Finally, let's do the time and space complexity analysis. So for the time complexity, we are just running a loop, and in the loop we are just multiplying it and adding it. So the overall complexity is order of n. And for space complexity, we are not initializing any arrays, so it's just two variables, so it will be constant. Time complexity is order of n, space complexity is order of 1. I also have the code in Python. If anyone wants to view it, I'll add it in the description as well. And let's catch up in the next video.